try to give you a few different phenomena you may see when you plot the energy file. So you will see sometimes rescale, so it's go up and then go straight down, go back up. So this is a normal. That's pretty much normal. It basically once it goes to really high number, um, then it will be rescaled to renormalized to a lower number and then keep growing again. This is the log plot in terms of time. Same for the other plots I'm going to talk about. And then sometimes you see the gaps. There's no curve in between if you do the log plot. The reason why is because it's a negative. This part is negative, like the q is negative, so you cannot have the log of a negative number in the with a real number. So yeah, that's what you have. It's normal. So those two are normal case, and sometimes you have no growth, or no growth or decay. So you either see something like this. If you see has a trend of like going up and then go down, then it means there's two mode competing and the stabilizing mode survives. So you can either change. You can consult to the desired mode not showing up, because if there's a two different mode competing, then you can try to exaggerate the mode that you really want to have, or the mode that want it to be unstable. Or sometimes you just see the really fuzzy block of noise, and that's also a signal of a no growth or damping. And this is the most important part. But as I said, I only have a really limited experience. So this is what I find over this about several months of learning that if you cannot find the desired mode showing up, then you can either change the resolution of the grid in terms of space, or you can changing the drive, like the temperature gradient, density gradient, or even collisionality and maybe even magnetic geometry. Or you can change hyperdiffusivity of Z and X. I tend to think the hyperdiffusivity can be seen as a buffer, and if you have a really fast growing small scale instabilities, then the hype Z or hype X will just buffer it out. Then there's maybe some desired mode that you can see. For instance, sometimes you have ETG that you don't want to see. You're just playing around with hype Z and X, and then it will damp out the ETG, but the MTM microtuning mode still will be existing. And you can also for nonlinear simulation, sometimes you can restrict the wave number range such that your desired range of a wave number, if it's strictly the desired wave number, then you will have a more desirable result. And sometimes you have a fuzzy plot. You just have really fuzzy, and then it doesn't converge. So basically, it's the two modes competing, two modes with a really with very similar growth rate competing. So what you need to do is just run for longer time. So if you run for longer time, you end up finding that one of the mode will survive.